Hi, geometry scholars. We're moving on to section 6.5. This is chapter 6. Today's topic is called Indirect Proof and Inequalities in One Triangle. So in 6.4, we did the mid-segment theorem. Now we're going to talk about inequalities, so how the angles and sides relate to each other within a triangle. As you can see, the core vocabulary is indirect proof. Also, you should have already known the word proof. We've gone over them all year. And then inequality means not equal. So hopefully in this next few minutes, you will learn how to write an indirect proof, how to list sides and angles of a triangle in order by size, and how to use the triangle inequality theorem to find possible side lengths of triangles. So let's go. Writing an indirect proof. So basically what you're going to do, it's called proof by contradiction, is you're going to temporarily assume that what you want to prove is false. Okay. And then go from there. You reason through it. And you find what we usually call logically is a contradiction. So if you start out with one fact and then you assume it's false and then look at the picture kind of thing, you'll always end up with something that just doesn't work. So if you end up with two falses, that's the same thing as true. We used to call this contrapositive in the truth tables. So they're actually my favorite kind of proof, if you do have a proof. And here's an example. We will be doing this together actually in our notes. Suppose a student looks around the cafeteria, concludes that hamburgers are not being served, and explains as follows. At first, I assume that we're having hamburgers because today is Tuesday. And Tuesday is usually hamburger day. There's always ketchup on the table when we have hamburgers, so I looked for the ketchup, but I didn't see any. So my assumption that we're having hamburgers must be false. This is indirect reasoning, or what we call an indirect proof. You start by making the temporary assumption that the desired conclusion is false, and then you show that this assumption leads to a logical impossibility, and you prove the original statement true by contradiction. So here's the steps. Number 1, you identify the statement you want to prove. Then you assume temporarily that this statement is false by assuming that its opposite is true. 2, you reason logically until you reach a contradiction. And then 3, you point out that since the desired conclusion must be true, since the contradiction proves the temporary assumption false. So if you have a false assumption proved false, then that means it must be true, logically speaking. Here we go. We'll do some examples. Here's an example of writing it out.
Write an indirect proof that in a given triangle, there can be at most one right angle. Given triangle ABC, prove triangle ABC can have at most one right angle. Solution. Step 1. Identify the statement you want to prove. Assume temporarily that this statement is false by assuming that its opposite is true. So assume temporarily that triangle ABC has two right angles. Then assume angle A and angle B are right angles. Step 2. Reason logically until you reach a contradiction. By the definition of right angle, the measure of angle A is equal to the measure of angle B, which is equal to 90 degrees. By the triangle sum theorem, the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Using the substitution property of equality, 90 degrees plus 90 degrees plus the measure of angle C is equal to 180 degrees. So the measure of angle C is equal to 0 degrees by the subtraction property of equality. You have reached the contradiction when you have two statements that cannot both be true at the same time. A triangle cannot have an angle measure of 0, so this contradicts the given information. Step 3. Point out that the desired conclusion must be true because the contradiction proves the temporary assumption false. So the assumption that triangle ABC has two right angles must be false, which proves that triangle ABC can have at most one right angle.
So hopefully you can see how that works. Keep going. We're going to write some of them together in our notes. Here's another one. And this idea is the second idea in 6.5. We're going to relate side length and angle measure.
Draw an obtuse scalene triangle. Find the largest angle and longest side and mark them in red. Find the smallest angle and shortest side and mark them in blue. What do you notice? Solution. To draw an obtuse scalene triangle, draw a triangle that has one obtuse angle and no congruent sides. For example, you can draw the triangle as shown. In the drawing, the largest angle is the obtuse angle, and the longest side is the side opposite the largest angle. So the longest side and largest angle are opposite each other. In this drawing, the smallest angle is located at the top vertex, and the shortest side is the side at the bottom of the triangle, which is the side opposite the smallest angle. The shortest side and smallest angle are opposite each other.
So if I was going to ask you, just by looking at a triangle, order the sides by length, the longest is across from the largest angle, the shortest is across from the smallest angle, and the other one's in between. So we actually have some theorems that says the longer side theorem and the larger angle theorem, and it's put into like this. So theorem 6.9, if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So see how 8 is bigger than 5? Then that means the angle opposite, which is angle C, is going to be larger than angle A, which is across from the 5. And that's the conclusion. There is one sort of common error here. Be sure that you don't confuse the symbol angle with the symbol less than. So be very careful with the notation here. The bottom edge of the angle symbol is horizontal. So the less than symbol is sort of kind of wonky. So if the angle is horizontal like this, that's the angle. And if it's sort of off kilter, that's the less than sign. So our other theorem on this is the opposite, but it's sort of the converse. If you have angles that are larger, so if you have an angle of a triangle larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So see how A is 50? That means BC is bigger than the side across from 30, which is AB. BC is greater than AB. That's an inequality. There's a proof here. Like I said, we're going to do it in our notes, so I'm going to save that. And here's an example of the type of problem you'll be asked to do.
You are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 32 feet long. The left slope is about 24 feet long, and the right slope is about 26 feet long. List the angles of triangle JKL in order from smallest to largest. Solution. Draw the triangle that represents the mountain. So draw triangle JKL. Label the side lengths. Look back at the problem. The bottom edge of the mountain is about 32 feet long, which means the length of side JL is 32 feet. The left slope is about 24 feet long, which means the length of side JK is about 24 feet. The right slope is about 26 feet long, which means the length of side KL is about 26 feet. The sides of triangle JKL from shortest to longest are JK, KL, and JL. The angle opposite side JK is angle L. The angle opposite side KL is angle J, and the angle opposite side JL is angle K. So the angles opposite these sides are angle L, angle J, and angle K respectively. The triangle longer side theorem states that if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So by the triangle longer side theorem, the angles from smallest to largest are angle L, angle J, and angle K.
we go. Here's another example with some numbers on it about having the angles and then ordering the sides.
List the sides of triangle DEF in order from shortest to longest.
Solution. First, find the measure of angle F using the triangle sum theorem. By the triangle sum theorem, the measure of angle D plus the measure of angle E plus the measure of angle F is equal to 180 degrees. Substitute 51 degrees for the measure of angle D and 47 degrees for the measure of angle E. This gives you the equation 51 degrees plus 47 degrees plus the measure of angle F is equal to 180 degrees. Use the subtraction property of equality, and the measure of angle F is equal to 82 degrees. The angles from smallest to largest are angle E, angle D, and angle F. Angle E is opposite side DF, angle D is opposite side EF, and angle F is opposite side DE. So the sides opposite angle E, angle D, and angle F are side DF, side EF, and side DE respectively. The triangle larger angle theorem states, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So by the triangle larger angle theorem, the sides from shortest to longest are side DF, side EF, and side DE.
Simple as that. Now, this theorem comes about because of those theorems. Now, when one of the things we've skipped this year is constructions. So you see these markings, and that's what you would make with a compass. You don't need to be able to actually draw them with a compass to use this theorem, okay? But there is a theorem that says, not every 3 lengths can form a triangle. Here's 3 examples. The lengths of the segment have to fit a certain relationship. For example, 3 attempted triangle constructions using segments with these lengths are shown below. So this works, but this does not, because 2 and 2 can't come together to make the 5. And this almost works, but the 2 actually will not, if you bring the 2 over here, it actually doesn't need it. So it has to be a little bigger than 5. So when you start with the longest side and attach the other 2 sides at its endpoints, you can see that the other 2 sides are not long enough to form a triangle in the second and third figures, which leads to the triangle inequality theorem. So here it is. The sum of the lengths of any 2 sides of the triangle is greater than the length of the third side. So if you add AB and BC, it's going to be more than AC. If you add AC and BC, it's going to be more than AB. And if you add AB and AC, it's definitely going to be larger than BC. And it doesn't matter. Any triangle will do this. It's called the inequality theorem. So you can figure out certain parameters for how to make a triangle work. There is a proof in example 47. We're not going to do it right now, but we will look at it in our notes. Here is how you would find those certain lengths, and this will be in your homework as well.
A triangle has one side of length 14 and another side of length 9. Describe the possible lengths of the third side. Solution. Let x represent the length of the third side. Draw diagrams as shown to help visualize the small and large values of x. Then use the triangle inequality theorem to write and solve inequalities. By the triangle inequality theorem, the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So in the triangle on the left, for small values of x, x plus 9 must be greater than 14. To solve this inequality, subtract 9 from each side of the inequality. This gives you x is greater than 5. Next, in the triangle on the right, for large values of x, 9 plus 14 must be greater than x. Combine like terms on the left side of the inequality, and 23 is greater than x, or x is less than 23. You can combine the 2 inequalities, x is greater than 5 and x is less than 23, to write the compound inequality 5 is less than x, which is less than 23. This can also be read as x is between 5 and 23. The length of the third side of the triangle must be greater than 5 and less than 23.
Again, that's it. You're just using that theorem to write an inequality. And I believe it's time for some homework. Again, I didn't do a lot of problems because there's 3 different concepts, but you can go to big ideas and you can work on that assignment now.